Okay. FWC paper, grade 13, March 2020. Second term paper, grade 13. And this is an essay question relating to humidity, concepts of humidity. Let's get started. This is the first part, A part, and it says state three methods by which an unsaturated vapor can be changed to saturated vapor. So A part first, right, three methods. How you have to convert unsaturated vapor to saturated vapor. So there are three things which impact the saturated or unsaturated nature of vapor. One is mm, by reducing temperature. By reducing temperature. Now what is the concept behind this? State three methods by which an unsaturated vapor can be changed to saturated vapor. Now, when you say unsaturated vapor, RH must be less than 100. That is what you call unsaturated vapor. And saturated vapor means RH is equal to 100. So, in in other words, you have to find a way to increase RH. How to increase RH? That is the question here. How to increase RH? Now, by reducing the temperature, you can convert an unsaturated vapor to saturated vapor. How? Let me explain that in green color within bracket. Now we know RH is equal to absolute humidity over absolute humidity of saturated vapor into 100. So when you reduce temperature, what happens is, the absolute humidity of saturated vapor will reduce, because absolute humidity of saturated vapor at a given absolute humidity of saturated vapor depends only on the temperature. So when the temperature is less, absolute humidity is less. Therefore, relative humidity will increase. Okay. The reason is because absolute humidity saturated depends only on temperature. That is one method, only on temperature. And when temperature is reduced, absolute humidity of saturated vapor reduces. How does it reduce? There's a graph for that. We have already covered that in our theory class. Temperature, absolute humidity of saturated vapor, the variation goes like this. It's not a linear variation. Nonetheless, when you reduce the temperature, it will reduce. That's one method. And the second method, by adding more water vapor. By adding more water vapor without changing the temperature or volume. Without changing the temperature or volume, we can add more water vapor. All right. So what happens there? Now we know RH is equal to absolute humidity divided by absolute humidity of saturated vapor. Absolute humidity is mass over volume, isn't it? Mass over volume over absolute humidity of saturated vapor. Why mass over volume? I mean, mass is mass of water vapor. Volume is volume of the room or chamber. Right. Now when you increase M, that is when you add more water vapor, RH is definitely going to increase. That is another method. And the third method is by reducing the volume of the chamber. By reducing the volume of chamber. By reducing the volume of chamber. Right. Now, what happens when you reduce the volume of the chamber without changing the temperature? Right. RH is equal to, again, AH divided by AH saturated. Right. Now, what is AH? That is mass of water vapor divided by volume of chamber over absolute humidity of saturated vapor. So as long as you don't change the temperature, the denominator doesn't change, the absolute humidity of saturated vapor. But when you reduce the volume, RH is going to increase because it's in the denominator of the above fraction. All right. So these are the three methods you can adapt if you want to convert unsaturated vapor to saturated vapor. Or in other words, if you want to increase the relative humidity from a number less than 100 to 100. Right. And the second part. I hope that is okay. And the second part, what do you understand from the term dew point? Right. Dew point is a temperature, isn't it? Dew point is a temperature. So you can say dew point temperature at which an air sample starts, air sample gets saturated with gets saturated with water vapor. That is the, yeah, temperature at which it gets saturated. I mean, that is not the only temperature at which it will be saturated, but that is a temperature at which it's saturated. If not, you can say a vapor and dew is at the verge of forming, and dew is at the verge of forming. Dew won't form, but air will be saturated. That's the interesting part when it comes to dew point. Dew will not form, but it is ready to be formed. Right, that is dew point. All right, but at dew point, RH is 100. Define relative humidity in terms of dew point. Define relative humidity in terms of dew point. Now, in the last class, we learned about relative humidity. There are four different equations for relative humidity. Now, they are asking us to define it in terms of dew point. You can give two equations for that. So, for relative humidity, I will use the acronym RH, right? So, RH is equal to, what is the first equation? Saturated vapor pressure. Saturated vapor pressure at dew point, and that must be divided by saturated vapor pressure at room temperature. That must be divided by saturated vapor pressure at room temperature multiplied by 100. That is the first one. So in this equation, both must be saturated vapor pressure, and numerator dew point, denominator room temperature. That is one. And not only this, if you can state that in terms of pressure, you can also state that in terms of absolute humidity as well. So you can write here, just put AH of saturated vapor at, again, dew point. I'll just put dP for the time being, dew point, and that must be divided by the same thing. Now earlier it was pressure, this time it's absolute humidity, but both must be saturated. Absolute humidity of saturated vapor at room temperature into 100. Right. So it's one of these two equations. You can use one of these two equations. It can be either be in terms of pressure or in terms of absolute humidity. But I think by the looks of this question in the upcoming parts, I think they were using the absolute humidity one, but they have not told anything like that. No? So it's totally fine. You can write one of these two answers in terms of dew point. That's why we are going for this answer in terms of dew point. The other equation says relative humidity is equal to unsaturated vapor pressure at room temperature divided by saturated vapor pressure at room temperature. If not, absolute humidity of unsaturated vapor at room temperature divided by absolute humidity of saturated vapor pressure at room temperature. So their dew point is not there in the other two equations. That's why they are wrong. This should be these are the two possible answers for this question. The figure 1 shows the cylinder containing air of volume 1 meter cube, right? Figure 1 is up. It had, there is a cylinder like this, a piston and all, like this, and it contains air. So we can change the volume of that air, right? They're saying it, we have air 1 meter cube at 20 degrees Celsius, having relative humidity of 60. So, yeah, relative humidity is 60. Initial relative humidity is given as 60 percentage. Okay. The figure 2 shows the variation of saturated vapor pressure of water vapor with temperature, right? Different temperatures and different corresponding saturated vapor pressures are given in millimeter mercury. The molar mass of water is 18 grams. Gas constant is 8.31 joules per mole per Kelvin. Okay. Density of mercury, 13,000. Use the data given and answer the following questions. Right. Let's get started. What is the dew point of the air inside the cylinder? First, we have to find that. Okay. Now, 20 degrees Celsius is the room temperature because it's at 20 degrees Celsius. So room temperature, 20 degrees Celsius. All right. So we have to focus on this value. And now we have to find out the dew point. Now, how do you do that? First part, Roman 1, you can go for the equation we wrote. RH is equal to saturated vapor pressure at dew point, dP, divided by saturated vapor pressure at room temperature. We can use these equations since we have already written that in for what length in this detailed manner. We can use this now. What is RH? It's 60. We don't know the saturated vapor pressure at dew point. So let's find that out. Divided by saturated vapor pressure at room temperature is 17.5 and into 100. Into 100. Right. Let's do some simplifications here. 60 and 100. If you simplify here, 5, here 3. All right. 5 and 3. And we have 5 and 17.5. If I simplify them, it will be a 2 here, it will be a 2 here and a 7 here because both can be simplified by 2.5, 2 and 7. Therefore, finally, you will end up in an equation like this. What is the equation? Saturated vapor pressure at dew point, that is equal to uh, 21 over 2. I'm getting 10.5 millimeter mercury. 10.5 millimeter mercury. All right, 10.5 millimeter mercury. And you can see 10.5 millimeter mercury is this. So, therefore, I can say dew point is going to be equal from the chart. You can find the dew point. How much is that? That is going to be 15 degrees Celsius. So these dew point questions and all, you have to humidity questions. You have to approach it using the graph. They will give you a graph from the you find the value, then you have to go back to the graph and get the answers. All right, done. Roman 2. What is the absolute humidity of air inside the cylinder? What is the absolute humidity of air inside the cylinder? Well, that is going to be equal to this because the equations. Well, there's another equation for RH. What is that? RH. Oh, no. We have to find the absolute humidity. No, we have to find the absolute humidity. Okay, now there's another equation that is this. Relative humidity is equal to absolute humidity of the air divided by absolute humidity of that air if it had been saturated into 100. Okay, right. So what is this all about? Now you can apply PV is equal to nRT here according to the information they have given. Right. So for absolute humidity, now PV is equal to, instead of number of moles, we can say mass over molar mass into RT. Then PM over RT, that gives you mass over volume. So that is actually absolute humidity, isn't it? Absolute humidity. Right. So instead of absolute humidity, you can use the equation PM over RT. PM over RT is the absolute humidity. So they are asking us to find that absolute humidity value. And remember one more thing. Now, right, not this equation actually. Should have compared the other equation. There is another equation for absolute relative humidity. Sorry, relative humidity. That is this. Uh, Vapor pressure divided by saturated vapor pressure. Vapor pressure at room temperature. Vapor pressure at room temperature over saturated vapor pressure at room temperature into 100. And also that is equal to saturated vapor pressure at dew point over saturated vapor pressure at room temperature into 100. Sorry, into 100. Therefore, when you compare these two equations, you can say vapor pressure at room temperature at this moment, it's equal to saturated vapor pressure at dew point. Now, if you are wondering how is it possible, now if your room is not saturated, let's say your room temperature is 20 degrees Celsius, all right, your room temperature is 20 degrees Celsius, and at 20 degrees Celsius you can have more water vapor. That's it, maximum water vapor is maximum amount of pressure. Now you can have high pressure, that means you can have more water vapor. Let's say maximum mass of water vapor is m1, whereas at a lower temperature, at a temperature like 15 degrees Celsius, the maximum mass of water vapor you can have it m2. M2. All right. I'll repeat. At 20 degrees Celsius, the maximum amount of mass of water vapor you can have is M1. At 15 degrees Celsius, the maximum mass of water vapor you can have is M2. So M1, M2, which value is larger? M1 is larger because at higher temperature, air can have more water vapor at higher temperature. Okay. Now imagine yeah, that's how it is. So if it is unsaturated, then now if this is the dew point, this is actually the dew point. If it is unsaturated, we will have that amount of that mass of water vapor here, m2 mass of water vapor here, if it is unsaturated. That's okay now. Now if it is dew point, if this is dew point, let's say this if 17 is the dew point on that particular day, And at dew point, you can have a maximum mass M2 at that place. For example, I don't know, so some value less than M1 definitely. So at 20 degrees Celsius, the unsaturated vapor will have M2 mass. If the mass of unsaturated vapor is M2, that means you can decide, okay, on that day, this should be the dew point. It should be 50 degrees Celsius, depending on the mass of water vapor we have in the unsaturated vapor. All right, that is what this equation means. Now, if you go back to this thing, now since we have found out the pressure of saturated vapor, at dew point, I can say the the vapor pressure at room temperature is equal to the same. That is how much? 10.5 millimeter mercury. 10.5 millimeter mercury. Now, pressure is in millimeter mercury, not the SI units. So I'm going to convert the pressure at room temperature to Pascal. Now, how do you convert it to Pascal? You can use the equation H rho G. H rho G. Height, density, G. Now, height. What is height? They have given 10.5 millimeter. So you have to convert it to meters. 10.5 over 1000. Multiplied by density. This is millimeter mercury. So density of mercury, you have to choose 13,000. And then multiply that by G. That is 10. All right, fine. So when you do that, what are the simplifications we can do? These zeros can be cancelled out, correct? These zeros can be cancelled out, and 100, 10.5 and 10 is 105 when you multiply them. And final answer for the pressure of room temperature, that is going to be 105 into 13 pascals. Yeah, you can leave it, but how do you find AH then? You have to find AH, absolute humidity, in kilograms per meter cube, right? So we need to convert it to pascals because R is in SI units. No? R is in SI units. So you have to go back here. Okay. Right. And then if you go back to this equation. Now, what is our purpose? Finding the absolute humidity. To find the absolute humidity, I need mass over volume. Right. So for that, yeah, okay. Uh, then I will go to this equation. So absolute humidity now, it's going to be equal to pressure 105 into 13 into molar mass 18. 18 grams per mole, that is 18 into 10 to the power minus 3 kilograms per mole, divided by R. R is 8.31. And the temperature is room temperature 20, that is 293 Kelvin. Therefore, absolute humidity, we have to find the final value after simplifying this. Fine, when you simplify it, finally we are getting our answer around 10.5 into 10 to the power minus 3 kilograms per meter cube in SI units. If not, you can say AH is approximately 10.5 gram per meter cube. This is normally the range we get the absolute humidity values. Okay, so if you're getting answers for absolute humidity, this is how it should be. Yeah, keep this in mind. It can't be high values. Your answer should be in this range, within this range, into 10 to the power minus 3 kilogram per meter cube for absolute humidity values for normal air. And if you're getting an answer very small or very large, then you should know that you have done something wrong. Right? So let's settle to this. Well, this is how you have to do this, approach this question. All right. Second question. What does it say? Find the new absolute humidity, relative humidity, and dew point when the volume of air inside the cylinder is changed to 0.6 meter cube without altering its temperature. Assume that the air inside the cylinder has not become saturated due to its volume change. Right. Now, for the second part, now we are going to discuss the second question. Room temperature is still same. What is the room temperature? 20 degrees Celsius. They have not altered it, so room temperature still remains same. Fine. Let's start then. If the room temperature is still same, then second question, there's only one question, right? Second part. If room temperature is still same, saturated vapor pressure is okay. Still, it's the same value. Saturated vapor pressure at room temperature, that is still the same value, 17.5 millimeter mercury. Okay. millimeter mercury. And then now in the earlier question we just discussed, in the earlier question we have discussed, here we go, the absolute humidity is what, 10.5 kilogram per 10.5 into 10 to the minus 3 kilogram per meter cube. Okay, so first of all, this is what's happening. Initially the volume was 1 meter cube, and now they are changing the volume to 0.6 meter cube, and the air has not condensed. They have mentioned in the question within brackets. Hope you read it. Assume that the air inside the cylinder has not become saturated. Okay, it has not become saturated. Therefore, the mass, now here the AH is found. AH is found, that is roughly 10.5 into 10 to the power minus 3 kilogram per meter cube. Therefore, people, what is the mass of water vapor we will have here? Mass of water vapor is equal to, now AH is equal to mass over volume. No? Mass over volume. Therefore, mass of water vapor is equal to AH into volume. Here, luckily, volume is just 1 meter cube. Therefore, mass of water vapor inside this is 10.5 into 10 to the power minus 3 kilograms. And that will be the same here as well, because the air did not get saturated, so dew did not form. Therefore, the mass of water vapor will still remain the same. It will not change. But now they have changed the volume. And what is the new volume? That is 0.6 meter cube. Hope you all understood this. Mass of water vapor inside the system will remain same. Why? The air did not get saturated, so no dew formed. It did not disappear. It will remain as it is. Let's start. Absolute humidity. Now the new absolute humidity, I will start here for volume, this volume. Absolute humidity, that is equal to mass of water vapor divided by volume. So mass of water vapor is same, that is 10.5 into 10 to the power minus 3 divided by volume is 0.6. All right, kilograms meter cube. The units are not that necessary, but it's okay. And what is the value for absolute humidity now? 105 divided by 6. 105 divided by 6 is 17.5 into 10 to the power minus 3 kilograms per meter cube. That is the absolute humidity. Okay, but they are saying air inside the cylinder has not become saturated due to its volume change. But the problem is, but but now the relative humidity is going to be 100 now, people, because we are getting the same answer, no? 17.5. No, divide. Yeah, correct. 105 divided by 6 is 17.5. So look at the value here, 17.5. Oh no, that is absolute humidity. Sorry. Absolute humidity. Now we have to go for pressure. If you find pressure, will it be more or less the same value? Yeah, we have found the pressure. Sorry, we have found the absolute humidity now. Done. That part is done. Now let's go to next point. That is relative humidity. We need to find the relative humidity. Since the air is not saturated, you can go for what? You can go for gas loss since the air is not saturated. So if you use, we are not changing the temperature. Let's use P1 V1 equals P2 V2. No? P1 V1 equals P2 V2. Uh, P1, the initial pressure here, I think we found it. It was 10.5 millimeter mercury, isn't it? 10.5 millimeter mercury. That was the initial pressure. We found it here. It's there. 10.5 millimeter mercury into volume is 1. P2, new pressure we don't know. I'll take it as P2 itself. And the new volume is 0.6. 0.6. So it's the same. Yeah. P2 is equal to 10.5 over 0.6. And we are getting 17.5 millimeter mercury. 17.5 millimeter mercury. I think what they are trying to mean by this statement in the bracket is no water condensed. I think they mean no water condensed. That's what they mean. But in actually the air has become saturated. You know why? If the pressure is 17.5 millimeter mercury now at 20 degrees Celsius, look at the saturated vapor pressure. This pressure is equal to saturated vapor pressure, na, people? Right? P2 is equal to saturated vapor pressure at 20 degrees Celsius. So, what is RH? RH is equal to 100%. It has just become saturated. The air has just become saturated. And what is the dew point? Dew point is also the same value. That is how much? 20 degrees Celsius. Earlier, the dew point was 15. because the volume was 1 meter cube. Now, when you reduce the volume, you are changing the composition of the water vapor inside that. You are condensing the water. No, you're compressing the water vapor there. So the composition changes. Therefore, with that, dew point will also change. Okay. So this is the answer for the second part. Let's start discussing the third part. So I'll circle it with green color, and I'll use this space to explain the third part. Right. What is the mass of water condensed when the volume of air is changed to 0.25 meter cube without changing its temperature? Right. Now, in the third question, what they are doing is they are going to compress it even more. They're going to compress it even more. Right. Wait. Before that, uh, okay, these are the two K conditions now. Right. So here the volume is 0.6 meter cube. RH is 100. It is almost saturated. Dew is not formed though. Mass of water vapor you have here is how much? 10.5 kilogram. 10.5 into 10 to the power minus 3 kilograms. Okay, right. Now the volume is converted to 0.25 meter cube. But remember, the temperature is not changed. The temperature is not changed. What is the temperature for both the instances? It is 20 degrees Celsius. Temperature is equal to 20 degrees Celsius. Here also they are maintaining the temperature as 20 degrees Celsius. But you should understand, now here it is almost saturated. Dew is ready to be formed. Now we have compressed it even more. So definitely there's going to be some dew here. Dew is formed. We need to find out the mass of that. All right, fine. If the temperature is now, and again, you should know this is a saturated vapor. Huh? Saturated vapor. We have saturated vapor here because dew is formed. So this is saturated vapor. Now, if this is saturated vapor, the absolute humidity of that has to be how much? Absolute humidity has to be this. It should be same, 17.5 into 10 to the power minus 3. Tell me why is that? Absolute humidity of this part, that is going to be uh, 17.5 into 10 to the power minus 3 kilogram per meter cube. Why is that? Because as long as the temperature doesn't change, absolute humidity of saturated vapor will not change. Absolute humidity of saturated vapor will not change as long as the temperature doesn't change. 2020. So here it is saturated now. Here it is saturated. At that time, the absolute humidity was how much? We found it. That was 17.5 into 10 to the power minus 3. So the same absolute humidity, it's going to remain here as well. It's going to remain here as well. All right, fine. So if I use that equation now, absolute humidity saturated is equal to mass over volume. Absolute humidity of saturated vapor is 17.5 into 10 to the power minus 3. And the mass remaining here, we'll take it as m naught. The mass of water vapor remaining here, I'll take it as m naught. So I'll put m naught divided by the volume of this is 0.25 meter cube. 0.25 meter cube. Right. Then m naught, that is going to be 17.5 into 10 to the power minus 3 multiplied by 0.25. So m naught, it's going to be equal to 17.5 divided by 4. When you divide 17.5 by 4, because 0 into 0.25 is 1 over 4. When you divide by 4, 4 point in 15, there is 375. 4.375 into 10 to the power minus 3 kilograms. That is the mass of water vapor which is going to be remaining in the system. Okay, that is the mass of water vapor which is going to be remaining in the system. So, yeah, okay. Then shall we simplify that and say 4.38 into 10 to the power minus 3 kilograms? Let's take it. No, never mind. We'll leave it that way. We'll leave it that way. So what can I say now? So mass of water vapor condensed is going to be how much? Mass of water vapor condensed, that is going to be uh, this is the amount of water vapor we had all this time. I mean, yeah, 10.5 into 10 to the power minus 3. We had that much of water vapor, and you subtract it, subtract the remaining water vapor from that. 4.375 into 10 to the power minus 3. So final answer, it's going to be 6.125 into 10 to the power minus 3 kilograms. That is the amount of water vapor condensed. So I hope you all understood it. What's the logic behind it? Let me repeat it. When you want to use the absolute humidity equation, it is mass over volume. True. Mass is mass of water vapor in the air. Right. Volume. Now here, both the temperatures are same. 20, here also 20. So in both of them, now both are saturated, remember. This is also saturated, the other one is also saturated. Both are saturated, huh? So as long as the air is saturated, the absolute humidity is saturated absolute humidity, and that doesn't change as long as you don't change the temperature. So AH values of both these situations will be equal. That's why I have written 17.5 and 17.5. How did this 17.5 come? We found it from the previous example, previous question, Roman, sorry, 2, right? And then using the volume given, I found the mass of water vapor which is remaining in the air. That is 4.375. There was 10.5 when the volume was 0.6, and now we have only 4.375. So the remaining water vapor should have condensed. Therefore, I subtracted 4.375 from 10.5, and this is the final answer. Fourth part. Let's use maroon color for fourth part. Presently, now we are here. We are here. Water has condensed. This much of water has condensed, and we have 4.375 into 10 to the power minus 3 kilograms of water vapor in the system. Presently, the condensed water vapor is removed from the cylinder, and the volume is changed to its initial value. Now, volume to its initial value. Initial volume is 1 meter cube. All right, we were starting at 1 meter cube, then it became 0.6, then it became 0.25. If they had said previous volume, it is 0.6. They are saying initial, so now the volume is converted to 1 meter cube. Find the present value of absolute humidity and the relative humidity of air. Okay, now once you remove condensed vapor, once you remove condensed water, what will happen? You will have now the volume is 0.25. Volume is 0.25. 0.25 meter cube, and the mass of water vapor inside, that will be how much? That is this, the remaining one, 4.375 into 10 to the power minus 3 kilogram per meter cube. And the water vapor is removed, taken out, and then you are changing the volume to its initial value, right? So what is the initial value now? That is 1 meter cube. So the volume is increased, and now the volume is 1 meter cube. And mass of water vapor inside the system, it's going to be still the same value. That is 4.375 into 10 to the power minus 3 kilogram. Sorry, not kilogram per meter cube. We are talking about mass. So it is just kilograms. Sorry. We'll have that many kilograms. Right. Now, what are we supposed to find out? Find the absolute humidity. Easy. Absolute humidity is equal to mass over volume. Mass is 4.375 into 10 to the power minus 3 kilograms divided by volume is 1 meter cube, initial volume. So the final answer is 4.375 into 10 to the power minus 3 kilogram per meter cube. And they are asking for the relative humidity. Guys, I think now there's a relationship between absolute humidity and pressure. When absolute humidity was 17.5, pressure also was 17.5. When absolute humidity was 10.5, sorry, vapor pressure. When vapor pressure was 17.5 millimeter mercury, absolute humidity is 17.5 into 10 to the power minus 3 kilogram per meter cube. And when the vapor pressure is 10.5 millimeter mercury, the mass was 10.5 into 10 to the power minus 3 kilograms per meter cube, something like that. Therefore, I think we can use the same relationship and write down the pressure, vapor pressure at room temperature. How much is that going to be now? We can say 4.375 into 10 to the power minus, so not 10 to the power minus 3, 4.75 into 4.75 millimeter mercury. Hope you guys understood that. I repeat, look at the values here. Huh? Here. When the vapor pressure was 10.5 millimeter mercury, absolute humidity was 10.5 into 10 to the power minus 3. When absolute humidity was 17.5 into 10 to the power minus 3, the pressure was 17.5 millimeter mercury. So you see a relationship between these numbers. correct? And this number as well, this number as well. So there's a relationship. Therefore, I think we can use the same relationship here as well. So 4.75 into 10 to the power minus 3 kilogram per meter cube is Ah. That means saturated vapor pressure is not saturated vapor pressure, vapor pressure is 4.75 millimeter mercury. Then let's finish it off. We are supposed to find out RH, find the present value of absolute humidity and relative humidity. What is the equation for relative humidity, people? Relative humidity is unsaturated vapor pressure at room temperature divided by saturated vapor pressure at room temperature into 100. So unsaturated vapor pressure is 4.375. Saturated vapor pressure is 17.5 into 100. I think the answer is going to be exactly 25 percentage. 25 percentage. All right, because we here we divided it. Hmm? So this 1 and 4 here, 25 percentage, and that will be the final answer.